Okay, so this is 75 from page 393. And this is a lot like the problems that we tackled. We're going to try and write ourselves a sine or a cosine function for this thing. So on a particular day, they gave us the high tide was at 7:12 a.m., low tide at 1:24 p.m. They gave us some heights there. I'm going to think of these. This is where military time is actually kind of useful, because my period, it's going to help me to know how far it is in between these two things. So why don't we start graphing these? Would you guys rather have this in hours and minutes, or would you rather have it in like hours as a decimal? What do you think? Decimal hours? Let's go ahead and do that. Let's change 7:12 into 7 point something. So 7 plus, there's 60 minutes in an hour. So 7 plus 12 over 60. Oh, that's 7.2. So we're going to use 7.2 for 7:12 a.m. And I wonder if you guys get why I'm using 13:24 instead of 1:24. Like it's afternoon, like military time, European time. 13:24. So 13 hours plus 24 60ths of an hour. Oh, look at that. That comes out really nice too, 13.4. I bet they chose those values so they would come out nice as decimals. And then they tell us that the period is 12 hours and 24 minutes, which would be, well, let's go ahead and change that into decimals to 12 hours plus 24 over 60, 12.4. Huh. That's interesting, because that doesn't really match with this, does it? Hang on. For this one, 12.4 would be the period. There's an implied parentheses. I mean, your calculator will do order of operations, so. So from here to here, oh, that is 6.2, isn't it? And double that would be 12.4. Okay, that's feeling better here. Okay. All right, so let's go ahead and start graphing this. So high tide. So I'm gonna start making a graph, and this is where I like these problems, because like I can just like make the graph look like whatever I want to, and then come back and label it later. So I've got information about a high tide. I'm going to say it starts here, and then it's going to dip down, and then we've got a low tide. So this is looking to me kind of like, I think I'm probably going to write a cosine equation for this thing. And they said that this one happened at 7.2. So on the x-axis, this would be at 7.2. And this one, this low tide happened at 13.4. That would be our 1:24 in the afternoon. And that is 6.2 apart, which is nice because they told us our total period was going to be 24.7. So, or sorry, 12 point. Where am I getting 24.7? 12.4. My brain's doing weird things today. Okay. So we got everything we need for our period. We need a max and a min. Luckily, they told us how deep the water was. It was 11 feet deep at high tide and 7 feet deep at low tide. We're going to need to know this center line, because remember, when we do our vertical shift, we shift to the center line, not to the bottom. That's a super common error, so keep an eye out for that. Halfway between 11 and 7 is 9. So I got all the pieces we need now. I'm going to need omega. Let me find that. Omega is 2 pi over whatever the period is, 12.4. Not a big fan of that. I'm going to multiply by 10 over 10 to get 20 pi over 124. We don't like decimals inside of fractions. That's why I did that. I can reduce this. Those are both divisible by 2. That would be 10 pi over Oh, 62. I can reduce it more. 5 pi over 31. And if I hadn't wanted to deal with all that, your calculator will do this for you, right? I could have just typed in 2 over 12.4 and then what? Math frac. And that'll change it into, 5 pi over 31. All right, so this is what I'll use for omega. So we set a positive cosine. So y equals amplitude looks like it's 2. 5 pi over 31 rather. So I need a horizontal shift and a vertical shift. The horizontal shift would be from 0, looks like to the right by 7.2, so minus 7.2. And decimals are fine there. That decimal's fine because it's not in a fraction. We just don't like decimals in fractions. And then vertical shift. And remind me again, do we shift to the bottom or do we shift to the center? We shift to the center, shift to the center. That was like #1 common mistake on Thursday. I think a lot of us made that mistake and learned from it, and we're not going to make it again, right? All right, we feeling okay about the equation? So what do they want? What was the first low tide on that day? So this must not have been the first one. This was high tide. So this must not have been the first one. So the first one would have happened one period before that, right? Which was 12.4 before that. So from 13.4, if I go back in time by 12.4, 13.4 minus 12.4 is, that's 1. Now they wanted a time. Does that correspond to 1 o'clock in the morning? Sure does. So 1 o'clock a.m. per day. Part B. What is the approximate depth of the water at 4 a.m. and at 9 p.m.? So they're really asking us to put in an x value for our function. 4 a.m. would be, well, we just put an x value of 4 into our function. And what will we put in for 9 p.m.? Not 9, 21. That's 21 hours into the day, right? When we wrote this function, we wrote a function where x was the number of hours after midnight. That's why we had to shift it over 7.2 because it was 7.2 hours after midnight that we saw that first max. So I would probably use my calculator to find those 2 times. I'll leave that part up to you. Part C, what is the first time on Labor Day that the water is 9 feet deep? So now we're looking for an x value when y is equal to 9. So, and 9 happens to be where the center line is. So we might actually be able to find this without, we could also use our calculator to do this, correct? We could graph this function, graph a line at y equals 9 and find the intersection. But I think we could do this just with this. This one's happening. I don't want to do that. I would use the calculator. I could figure out where this is. What's halfway between 7.2 and 13.4? That would be 10.3, I think, right? And if I take 10.3 and I back it up a whole period, that's going to get me negative. No, so I would back it up a half a period. I think the answer is going to be 4.1, but yeah. Well, 4.6. Yeah. And then we would want to turn that into, so that's 4 plus 0.1 times 60, which is 4. So that'd be 4:06 a.m. in the morning. Fun. Okay. Okay. What else did you have questions about from the homework? Those 4 that I put on Canvas, did you guys do all right with those? Those ones were easier, I think, than what we were graphing before. Do you agree with that? That's what our homework's going to look like today. So when we graph sines or secants and cosecants and tangents and cotangents, I'm just going to have you draw them and label the axes after the fact, which is way easier, I think, than trying to squeeze them into an axis that I give you ahead of time. All right, any other questions from the homework before we dive into this new stuff? Yep.
How do you want to check the sinusoidal challenge?
You're going to turn that into me by Wednesday at the end of class.
Oh, so
yeah. Yeah. Or if you want to drop it in the tray today, that's fine too. There is a sinusoidal challenge page on the back of those word problems that we did on Thursday. That's just optional points. I'll put it in the test category. And if it's done, I mean, I'm going to give you the full credit. I mean, unless it looks like you just randomly filled in numbers or something like that. Yeah, so feel free to drop it in there. Okay, we ready, guys? You ready? Let's do this. Let me start a new video here so I can post those separately.